Question 6 on the practice exam is a statistical process control question, and we'll calculate our upper and lower control limits for an X bar and an R chart for this problem. So we're given some information here. We've got an oil change company. We want to get the oil changed in 15 minutes on average. We've collected a sample of 20 days and record the performance of 5 randomly selected workers. All right, so that's what we've got here. So we've got 5 subgroups here in this. These are the 5 randomly selected workers over 20 days. So if you were thinking of how we had these charts in class, you'd have days 1, 2, 3, 4 to 20. And then across here you'd have worker 1, 2, 3, 4, and 5. And you'd have some result in each one of these and calculate an average, an X bar, and a range for each of the observations here. So that's what all of that would look like, just for a background here. And now we can start looking at what is the problem asking us to do here. We're not going to create the charts themselves, but we're going to look at here. We're going to look at calculating the upper and lower control limits for the X bar chart and the upper and lower limits for the R bar, or R chart, excuse me. And to do that, we're going to use these formulas here. So this is for our X bar chart, our upper and lower limits, and this is for our range chart. Okay, so let's do X bar first. So what we're going to do, we'll do the lower control limit first. And what that will be then is we will, let me get the numbers on there for us. Okay. So in this case we'll have the grand mean, which is the double X bar here. So we have, and that is this value here, 15.11. And then we will add, excuse me, for the lower, I said we would do the lower control limit first, so let's do that right here. Minus A2.577 times our R bar value, 6.4. Close parens. And then for our upper limit, so let's say LCL, it's supposed to be a C, and then our upper control limit is going to be the same, but we're adding, right? 15.11 plus 0.577 times 6.4. And this is the equivalent, if you remember, of doing a confidence interval, right? So we're going to have ultimately, if we were to create this chart, we would have something that looked like this with a upper control limit and a lower control limit. And then right in the middle here, well, that's not exactly the middle, but we would have the X bar, the grand mean here of 15.11, and then plus or minus 3 standard deviations around that is going to define our limits of our process measure here. All right, so again, just some background for you on that. So if we move down here, then we'll just finish calculating these. So the, come back, the LCL, this one right here, if we multiply all of that out, the LCL is going to equal 18.8, and excuse me, the upper control limit is 18. This is the result here of the upper control limit, 18.8, and then the lower control limit is going to be 11.42. Alright, so again, if we just go back over to this, just to illustrate what we've just done here, this value is going to be 11.42, and the upper is going to be 18.8. Okay, and so this is in minutes. So again, this is this oil change problem here. So we've got in the middle, our sample is 15.11 minutes, the average of all of these together, and then plus or minus 3 standard deviations in either way is going to be, the process is going to be between 11.42 minutes and 18.8 minutes if it is running within control, or normal process variation would be within those plus or minus 3 standard deviations. Okay, so that's our calculation there of this is all for the X-bar chart. And now let's go back and look at what else do we need to do here. Okay, we need to do the same thing, calculate our upper and lower limits now for the R chart. And that's when we're going to use these equations here. And let me erase this for a minute here to highlight what it is we'll be looking at, if it will let me. Okay, well, I'll just circle again what we're looking at here. We are looking at, for our upper control limit, I'll just put these in triangles here, D4 and D3 for this particular group. And then we're going to be using the range, or the R bar, for our group. So to do that, I'm going to just move over to the side here. And again, we're doing the same thing here. We're going to have a chart that looks like this. We're going to have this 6.4 in the middle, and then we're going to have a lower and upper value. And we know here, because this value is 0, because of our subgroup size is 5, and so we just know that that's going to be 0 from the table. And that's given to us here in the problem. But our lower control limit for range is going to be 0. Right, and practically speaking, we can't do an oil change in less than 0 minutes. So that's the lower limit in this case here. So 0, and then we have to calculate the upper control limit as well. So to do that, as I mentioned, so the lower control limit, we would calculate that by saying D3, which is 0, times 6.4, which is the 0 right here. And then we're going to say the upper control limit is 2.114 times 6.4. And our result there is going to be 13.53. Hopefully I can write that a little bit better for you, or attempt to. So that should be upper control limit 13.53. When you multiply 2.114 times 6.4, you get this result here. Okay, so these are our upper and lower control limits for the range, the variation in this process. All right. Now, so we've answered these first 4 parts of the questions. Okay, so now we're given some interpretation part of this. If your data collection yields an X-bar of 17.2, the process would be considered in or out of control. All right, so again, if we look back to what we calculated here, we had an upper control limit of 18.8 and lower of 11.42. 17.2 would be somewhere above the grand mean, but it's not out of control, right? It's within our upper and lower control limits, and so therefore we would say that this 17.2 would be in control. That is, we would say that would be common cause, not special cause variation. Right? We would expect some variation around that 15 minutes. That 17.2 is within our control limits. All right, now for the range question, we've got if the data collection yields an X bar, actually that should be an R bar, or a value, and a range right here of 13.98, excuse me, the process would be in or out of control. So again, looking up here, we had 13.53, or 0 to 13.53. Again, if we were to draw that like a 0 to 13.53, and we had something that fell outside of that at 13.98, that would be out of control, right? That is outside the control limits, and therefore that result would be said to be out of control, and investigation would be required.